So, I agree. One of the most important things in chemistry that you're going to come across and some people may have a problem with is balancing equations. Now, it's like a seesaw, really. It's like in order for a reaction to completely take place, it has to be balanced, right? It's like, as I said, a seesaw, you know? It has to have the same weight on both sides, really. So what's on the left side should also be on the right side of the equation, right? It's kind of like keeping a balance in your life as well. As soon as one thing goes off, it throws off the whole balance. And if the equation is not balanced, then you wouldn't be able to achieve the natural goal of the reaction, really, right? So there are steps in balancing an equation if you want to look at it that way, right? So these steps are as follows. The first thing you'll want to do is identify the most complex substance. Beginning with that substance, choose an element that appears in only one reactant and one product, if possible. Adjust the coefficients to obtain the same number of atoms of this element on both sides of the equation, more or less. Balance polyatomic and atomic ions if present on both sides of the equation, the chemical equation, as a unit. Then you will want to balance the remaining atoms, usually ending with the least complex substance and using fractional coefficients if necessary. However, if a fractional coefficient has been used, multiply both sides of the equation by the denominator to obtain whole numbers for the coefficient, because you can't have half an element, right? It doesn't make sense. You really can't have half of a hydrogen atom or half of a copper atom or even half of a silver atom. It just does not work that way. So you just multiply throughout by whatever number is necessary to get a full number, a whole number, right? And then lastly, count the number of atoms on each kind on both sides of the equation to be sure that the chemical equation is balanced. Okay? So for example now, we have this equation right here. We have copper solid reacting with silver nitrate. Now, the numbers in front of the equation are the coefficients. Those you can change. You can add numbers, you can multiply numbers. You can add numbers there. However, the subscripts, which is the number that actually forms the formula, you cannot change. If you change it, you're changing the entire equation and the chemical properties of that compound. Now, you cannot change subscripts in a chemical formula to balance a chemical equation. You can change only the coefficients, which I've just said. Changing subscripts changes the ratios of atoms in the molecule and the resulting chemical properties. For example, water H2O and hydrogen peroxide H2O2 are chemically distinct substances. H2O2 decomposes to water and oxygen gas when it comes in contact with the metal platinum, whereas no such reaction occurs between water and platinum. So right there we can see that if you actually change the subscripts of the molecule, of any element in the molecule, you will end up with a different compound on the whole. So keep that in mind. We only change coefficients, not subscripts. So let's move along now and dissect these steps on what we just learned. So, example 741, combustion of heptane. Balancing the chemical equation of the combustion of heptane, which is C7H16. And this is the equation right here. We have C7H16 liquid plus oxygen gas, because in order to burn anything, you need oxygen present, to give us carbon dioxide and water. So, as the first step said, identify the most complex substance. The most complex substance is the one with the largest number of different atoms, which is heptane, the C7H16. We will assume initially that the final balanced chemical equation contains one molecule or formula unit of this substance. Now excuse the error of the equation being written twice. So the next thing, second thing, adjust the coefficients. A, because one molecule of heptane contains 7 carbon atoms, we need 7 CO2 molecules, each of which contains 1 carbon atom on the right side. So we have heptane plus oxygen to give us 7 carbon dioxide plus H2O. Now we put a 7 there to get the same amount on the left side, because there's 7 carbon in heptane, but there's only 1 in carbon dioxide. So we put a 7 in front of it to get the 7. So you have now 7 carbon atoms on both reactant and product sides. Right? So because one molecule of heptane contains 16 hydrogen atoms, we need to put an 8 in front of the water molecule, each which contains 2 hydrogen atoms. So when you put an 8 in front of it, now we have 16 hydrogen atoms on both sides of the equation. But now we have 7 by 2 is 14 oxygen atoms plus another 8 oxygen atoms, giving us 22 oxygen atoms. That's not balanced. We have only 2 on the next side of the equation. So as the next step says, there are no polyatomic atoms to be considered in this reactant, however. So as the next step, moving on to the step 4, balance the remaining atoms. The carbon and hydrogen atoms are now balanced, but we have 22 oxygen atoms, as I said before, on the right side and only 2 on the left side. We can balance the oxygen atoms by adjusting the coefficient in front of the least complex substance, which is oxygen O2 on the reactant side. So if we just put an 11 there, because 11 by 2 gives us 22, we have 22 atoms on both reactant and product sides. And the last step is to check your work. The equation is now balanced, and there are no fractional coefficients. There are 7 carbon atoms and 16 hydrogen atoms on both sides and 22 oxygen atoms on both sides. So now this equation is balanced. So we can do a next example. So let's take a little while to digest that. Watch it good. Let's go over the steps. We'll go over the steps again in another example. So let's go. Balancing equations as we continue. So we're going to do the combustion of isooctane. Now the equation of isooctane is C8H18, and as we require for combustion, as I said, O2 gas. So let's go on. The assumption that the final balanced chemical equation contains only one molecule or formula unit of the most complex substance is not always valid, but it is a good place to start. The combustion of any hydrocarbon with oxygen produces carbon dioxide and water. And this is basically the process that takes place in a vehicle or any combustion process, as I said, relating to hydrocarbons. You're always going to get carbon dioxide and water as a product. So let's go again. Step 1. Identify the most complex substance. Now, in this case, the most complex substance would be the one with the largest different number of atoms, which is the isooctane, the C8H18. We will assume initially that the final balanced chemical equation contains one molecule or formula unit of this substance. So let's go again. The first element that appears only once in the reactant is carbon. No, we are carbon, right? So the first common sense thing to do would be to drop a 8 right in front of carbon dioxide because we only have one carbon dioxide on the product side of the equation, right? So that's the first thing we did. We added 8. But now, we now have 16 oxygen there and 1 from water. So, we'll get to that just now, which are not balanced yet. So we have 18 hydrogen atoms to deal with in isooctane, which means there must be 9 molecules in the product of water. So we drop in a 9 by the water. So we get 18 hydrogen atoms, right? Wait. Now we have 9 oxygen there and 16 oxygen there. 9 plus 16, if I know my maths as well, it's 25. Yeah, 25 there. But we have 2 over there. How are we going to balance this one now? It's not as straightforward as the last one, isn't it? But we go get there, man. We go get there. Don't worry. Don't worry. Take it a step by a time. Take it a step. Think it through. Let's remember this is basic maths we're doing, huh? Basic maths. So, there are also no polyatomic ions as in this unit. So, we move on to step 4. Balance the remaining atoms. Now, the carbon and hydrogen atoms are balanced, but we need 25 atoms of oxygen on the right side and only 2 oxygen atoms on the left side. So we need to balance that, right? But because there are 2 oxygen atoms per oxygen molecule, we must use a fractional coefficient to balance the atoms. So we drop, now it may show that we're using 25, but what we're really using there is 12.5. But if we put a 12.5 there now, when I multiply that by the 2 oxygens there, we get the 25. But we can't leave a fraction, right? So what they did, as I said before, is we multiply the whole equation by 2. So everything in this number in this equation will be by 2. In this case, they put 25 over 2. So when you multiply by 2, you would get 25. Or you can just put 12.5 or 12.5. But it's still multiplying throughout by 2 to balance off the equation. So when you multiply throughout by 2 now we're going to get 2 molecules of isooctane. We're going to get the 25 O2 gas. Now we're going to have 16 carbon dioxide molecules being produced and 18 water molecules being produced because everything now is multiplied by 2 throughout the whole equation. And now This has balanced equation in the end. The balanced equation has 16 carbon atoms, 36 hydrogen atoms, and 50 oxygen atoms on each side. Now, balancing equation requires some practice on your part, as well as some common sense, because as I said, this is basic maths. We are trying to get the same number of atoms of each element on both sides. If you find yourself using large coefficients, if you have spent several minutes without success, go back and make sure that you have written the formulas of the reactants and products correctly. Because if the equation to start with is wrong, then how could you balance the equation to begin with? So it has to be right to be able to get it right. So 95 steps. Once you have these 5 steps understood, you should be able to balance almost any equation. Again, it's some common sense in your part. The steps will always remain the same, but it's up to you. And eventually, you'll be able to watch these equations and be like, I know what goes where. You don't even have to go through the whole process of going through this like that. You just watch the equation and you know what numbers need to go where because you're so familiar with it. Please excuse my voice. A lot of talking is exhausting. So let's move on, shall we? So let's start with these simple exercises. In the first section, we're going to see they're asking us if these equations are balanced. Now let's start with the first one. So we have hydrogen in its liquid form and oxygen in its gaseous form to give us H2 to give us H2O2. Now this shouldn't be solid, this should be liquid because this is hydrogen peroxide. And yes, this equation is balanced because there are 2 oxygens here, 2 hydrogens on both sides. Now, for the second equation now, we have ethene, which is C2H4. Now, ethene is a gas. And then we add in oxygen because we want to burn it. Right? Now that produces 2 carbon dioxide plus 2 water molecules. Now let's watch this equation properly. Does this equation look balanced? Let's count and start with the largest complex one. So we have 2 carbon on this side and 4 hydrogens. We have 2 carbon on this side and we have 4 hydrogens on this side. We have, however, now watch it properly, yeah? That's 4 oxygen plus 2 oxygen. That gives us 6 oxygens. However, they only placed a 2 in front of that oxygen on the left side, on the reactant side. So that equation is not balanced. What in fact they should have put there is a 3. Because there are 6 oxygens on the next side, but there are only 4 on this side. So that's equation number 2 with ethene is not balanced. And then for the last one, we have magnesium nitrate reacting with lithium to give us magnesium solid and 2 lithium nitrate. Now let's see if this equation is actually balanced. We have two lithiums on, let's start with the magnesium nitrate. We have one magnesium and two nitrates. We have on the reactants and the product side, we have one magnesium and two nitrates. We also have two lithium ions, and we have two lithium ions over there. So this equation is balanced because we have two nitrates on both sides, we have two lithium ions on both sides, and we have one magnesium on both sides. That's cool. That's cool. And now we're going to work on these. We're going to balance these equations. So we have three equations here, and we're going to balance each one. So let's observe these equations one by one. So let's have a look at these equations. We have nitrogen gas reacting with oxygen gas to give us NO2 gas. So look at this. How would we go about balancing this equation now? We have two nitrogens and two oxygens. Now the oxygens is balanced already, but the nitrogens are not balanced. So what we will want to do for this equation is do it like this. So we have N2 plus O2 giving us NO2, right? So to balance these nitrogens, we will just want to rest a 2 right here. Now we have 4 oxygens on this side because we put a 2 there. We only have 2 oxygens here. So you'd also want to write a 2 right here. Now we follow the steps. Watch the most complex unit, which was this. And then we place the coefficient because we only have 2 here. We have 2 here, but only 1 here. So to balance that, we would put the 2 here, which we have right here. And then after that, we end up with 4 oxygens on this side. So we put a 2 here because it's the least complex substance, and put a 2 right here. And now we have 4 oxygens on both sides, so this equation is now balanced. So, cool, easy one, right? Let's move on to the more tougher question now. Let's see if we can balance this big one here. So we have lead nitrate reacting with iron chloride to give us iron nitrate plus lead chloride. Now let's start with the biggest one. The most complex substance, which is the iron nitrate, and start there. So in this equation, we have 3 nitrates, but we only have 2 nitrates over on this side, right? So we'd want to balance that first. So let's write over the equation. We have P, B, in brackets NO3 with a 2 there. So that means you have 2 of these here. Plus F, let's give a little more space. Plus F E C L 3. Okay, I could write that a little better than that. Right. FeCl3 to give us Fe in brackets NO3, that's 3 on the outside, plus PbCl2. Right? So let's balance this equation, shall we? So we have 3 nitrates on this side and 2 nitrates on this side. So how would we go about balancing that? Well, we could simply add a 2 here, which will give us 6 nitrates on this side. And we can add a 2 here, a 3 here, sorry. So we have 6 nitrates on both sides. Now, we have 2 iron here, right? But we need 1 iron on this side. So, we want to put a 2 on here, and now we ions are balanced, the nitrates are balanced. But we still have lead and chlorine to deal with. Now on the reactant side, we have 1 lead and 2 chlorine, but we have 3 lead and 6 chlorine on the other side. So what we'd want to do is add a 3 here. And now the equation is balanced. We have 3 lead, 3 lead, 3 by 2 is 6 chlorine, 2 by 3 is 6 chlorine. Right? So that's balanced. We have 3 nitrates, 3 by 2 is 6 nitrates, 2 by 3, 6 nitrates, that's balanced. And now we have iron. We have 2 ions, 2 ions. This equation is now balanced. Cool? And now we could go on to the last one. We have C6H14 react going under combustion to get our usual carbon dioxide and water. So we start with, as usual, the most complex compound. So that's the C6H14. So let's balance this. Let's write this again. We have C6H14 plus oxygen for combustion to give us carbon dioxide plus water. So let's start with the most complex substance, as we said. So we have 6 carbon and 14 oxygens. So to balance these carbons, we start in here, watching carbon dioxide in most reactant side. We would want to put a 6 here. Right? So we have 6 carbons on both sides. Now we have 14 hydrogens here, but we only have 2 here. So we want to put a 7 here. So we have 14 hydrogens on both sides, 14 hydrogens on the side. But, and here the problem starts, we have 2 by 6 is 12 oxygens, and then we have 7 oxygens, which makes 19 oxygen. How are we going to get 19? Now, we have 19 oxygens, right? So what we'll do is we'll get a fractional in front of the oxygen on this side. So you'll put 19 over 2. But we can't have a fraction, so we have to multiply the entire equation by 2 to balance it off, as I said earlier. Because we can't have fractions, we have to get whole numbers. So multiply the entire equation by 2. So now we're going to have 2 C6 H14, because we can't change subscripts, we could only change the coefficients, plus 19 O2. Now we have 12 carbon dioxide, and we have 14 water molecules. So in total on both sides now, we have 12 carbons on both sides. We have 28 hydrogens on both sides. And now we have 38 oxygens on both sides. Right? So that was our lesson for today on balancing equations. For more, you can subscribe to see other videos. And this is where I'll leave you all today. Please review the steps and take your time when balancing equations.